Thanks to everyone for joining today. As Noah was mentioning, my name is Ted Lee. I lead the AI team over at Second Dinner, and today I'm going to be talking about how we have evolved the shop experience in Marvel Snap. So, quick disclaimer, I play the game a lot, I love the game. I watched quite a few Marvel movies, but I definitely do not know enough about Marvel to make a funny name for the presentation, so I actually asked ChatGPT for this, so if the joke is not great or like there's not evolving that happens in X-Men, blame OpenAI. Anyways, we don't have too much time, and then we had this whole thing with the break, so I'm going to get straight into it. We're going to skip the agenda. First question that a lot of you might be asking is, okay, what is Second Dinner? Like, who are you? If that is your first question, there is no offense taken. We are a gaming studio that is based out in Irvine. We currently have one game that is launched. It is Marvel Snap. It is a competitive card-based game that has some elements of bluffing and betting. And what's most important to some of our core identity is that we are a small game company. Something that our company values extremely highly is keeping our teams extremely small so they can work together very closely, iterate, and launch games quickly. But having a small team and wanting to make big games introduces new challenges into what we want to do.
You did it, Bob.
When you can't just hire more people to solve the problems, we need to figure out other ways that are more creative. So how can we, make every single one of our teammates be able to have this entire drone of people or machines to do the work for them? Or how can we give the Tony Starks that we hire their own Iron Man suits so that they can be super productive at their jobs? In a lot of the times, the answer to that really is, getting good technologies, getting good platforms. In our case, we rely heavily on different managed platforms to tackle a lot of the work that we need to do. Managed platforms are super useful for us because they kind of replace the need to hire out massive teams to manage and work with different infrastructure. And of course, we're at a summit being hosted at Databricks, so I will be talking about how Databricks is being used as one of our platforms to facilitate a lot of the work that we do. So everyone's already probably familiar with a lot of the things that Databricks can do. We're using it to ingest all of our data. As those first talks were talking about, we have a lot of first-party data, but we also have to consolidate it with different pieces of third-party data, whether that's advertising or different pieces of information that we get from different partners that we have. We do a ton of data processing. Obviously, we need to clean up that data, dedupe it, figure out how to use it well. We turn those into analytics and dashboards so our downstream users can do it. We do monitoring and alerting based off of Databricks as well to make sure that certain core KPIs or performance metrics trend properly. We do machine learning. We use their model registry. We do a bit of model serving at this time also. And we've even gotten to dip our toes into training and fine-tuning some LLMs, both on the Mosaic Cloud platform as well as on the Databricks fine-tuning API. That's too much to cover just today, though, so I'm going to be talking about one use case that uses data processing, analytics, and machine learning. And as I kind of alluded to in the initial title slide, today we're going to be talking about shop personalization, and I'm going to take you through the journey of what we did in Marvel Snap, both the bad stuff, the stuff we had to do temporarily, and kind of where we're at and where we're headed towards. So to give you a little context about what Marvel Snap looks like, it's a card game, as I mentioned earlier, and most of our revenue comes from selling variants or cosmetics that are attached to different cards. Every single day, as the daily offer shop kind of implies, we give you daily offers of variants in your shop. There's 8 slots that are dedicated to new cards given every single day. It refreshes every single day. We have thousands of variants that are currently available, and we also constantly release them. So we're releasing anywhere between 30 and 100 cards every single day. You can imagine this turns into a massive optimization problem. To just give some rough numbers, let's say, for example, we're at a world where we have 4,000 variants and you show 8 of them a day. If your customer really wanted to give you money and buy one specific card, it's going to take them on average 500 days to find that card in the shop. That is probably not a good monetization strategy, and you might be very poor. So, obviously, we want to figure out how do we actually give these variants that players want to them without them being able to automatically choose them, because we think that there's some interesting and novel factors from having a randomly generated shop. So this is kind of how it started out. We started with a very manual and heuristic-driven process that we were used to kind of personalize the shop in some ways. So we've got the game, Marvel Snap. People are playing it every single day. They're interacting with it every single day. We're collecting a bunch of data about them. We're turning these into dashboards, and we've got an entire team of analysts or product who's looking at those dashboards. They're gathering whatever insights, and they're like, I think there's a new opportunity for us to sell more cards. They pitch that over to the engineering team. The engineering team scopes it out. They build out the work. They ship it. They need to find the next release cycle that's actually able to jump onto and push this out. And finally, this new feature is shipped to players. For example, we might be collecting data. We're looking at the sales. Someone notices, oh, this card, all these cards that are selling from this one artist, Dan Hip, they're doing amazingly. Let's just do a special event. So every single day you generate a shop, there's like a 5% chance that your shop is going to be all Dan Hip because people love Dan Hip. That's like, cool idea. The problem with this is this takes a long time. So we're doing ingests both on an hourly and a daily basis. We're populating and updating our dashboards on a daily basis. Having someone look at these dashboards and identify stuff might take days to weeks. Implementing a new entire feature for every single time we want to improve the shop might also take days or weeks. And we only release major updates to our client every 2 to 4 weeks. This means that one pass of this might take weeks to even a month. This is obviously not great if you want to go fast. This is not great if you want to have a small team and you don't want to have to hire an entire or scope out an entire project with the engineering team every time you want to release a feature. As I said earlier, it might take so long that you might only get 10 shots, right? It's probably not great if you only get 10 shots on goal in an entire year to optimize your shop. Also, with the lag time, there might be, by the time you launch your feature, it might not even be relevant. Maybe people really like Dan Hip because he just did some massive art expo, and a month later, he's not really that hot. He's actually still popular, by the way. The other thing is these aren't fully personalized. People are looking at aggregate statistics across the game. They're identifying, these are these niches or these characters that are really popular. It's not on a one-to-one basis. We're not building something just for each user. And on top of that, there's tons of manual steps. Someone needs to look at these graphs. What if the graph is messed up? What if their interpretation is different? We have to push and ship code every single time, and there's tons of manual steps. Tons of opportunities for mistakes, tons of opportunities to mess something up. And so what we wanted to do first was we wanted to figure out how can we change the system where we can have a shorter loop that updates more things and make it more personalized to players. And so you can see I split this loop into 2 sections. There's a left loop and the right loop. And what we've really tried to optimize is that left feedback loop that goes in and out of the game. So in this one, we once again log data from the games. Instead of going only to a dashboard that someone's checking, we build some sort of model, and we'll go into details about all the different ways you can do that, but we build some sort of model that is receptive to the data, right? That is taking that into consideration. It is updating whether it's some weights, whether it's some heuristics, whether it's some statistics, and being super dynamic, being super responsive to the ways that players are playing every single day. The way we build this model not only is dynamic and responsive, but it's automatically hooked into the game to make updates to it. So we've now got this cycle where new recommendations can be generated on a daily basis, or even more frequently if we wanted to, based just on what players are doing. On the right side, though, we still want to have this manual intervention, right? Just because we launched something that might be personalizing something for your shop, that doesn't mean we've launched the best version of it. Maybe the model needs more updating. Maybe we didn't consider that, our first model was just built based on what people are playing, and it turns out a lot of people like to just collect card art like art collectors. You might have to also make a bigger loop to improve the entire architecture or the system that you've been using. And so that's where this pink loop on the right happens. So once again, we do continue to update dashboards. We do continue to update reports. People do continue to look at those. And when they do find massive opportunities for change in terms of the model, in terms of the data that we feed to it, we plan and scope that work out. This allows us to have this hourly/daily loop on the right, while we still have this weekly or monthly loop on the right. Hourly and daily on the left with a weekly or monthly loop on the right. So earlier I talked about, we've got these different types of models that we're using. I'm going to walk you through 3 of them. These aren't everything that we've tried, but it does give you kind of an idea of a lot of the different things that we've taken at different points in our kind of journey that increase in complexity, that allow for more personalized things, but at the same time, the things we talk about first, these are things that you might be able to build in literally less than a week in some of these cases. So First off, I'm going to talk about what we did for daily population level recommendations. So I want to be clear, this is population level, so we actually cohort our players, and so we do not do a one-to-one recommendation. This was done so that we could do something as quickly as possible, so we didn't have to worry about shipping out millions or tens of millions or hundreds of millions of recommendations around the world, or figure out how to set up a live endpoint, which is not the hardest thing in the world, but if you're worrying about all these people and all of the people refresh the shop at the exact same time, you got to deal with all these things, right? So this was our first approach. We did a lot of cohorting. We did some analysis beforehand. This is that right side of the loop that takes longer. We figured out across different player metrics where you were located. You know, people in the eastern half of the world prefer anime-style art, for example. People in the western might prefer stuff like Howard the Duck. I don't know. Only people in America like to buy Howard the Duck stuff. We did it across different collection level bands, where collection level is sort of how far you've progressed into the game, because based on how far you've progressed, different cards are important or meta. And again, we kind of followed that loop that I talked about before. So we have this game, we collect a bunch of data. The simplest version that we started with, just looking at which cards were purchased. We just looked at every single time a card was purchased, every single time a card was shown. You can divide the two numbers and you get your purchase rates. We need to do a little math to clean it up, you know, normalize it, maybe apply a log function, remove outliers. Nothing too fancy. And then we created a system that allowed us to pre-generate these on a daily basis, ship those, and so on the right, that's representing sort of all of our different servers across the world. We're using basic key value stores because those are just easier to set up than endpoints. And this way, we were able to, in less than a week, set up a relatively personalized system, at least to different segments of players around the world, that updated on a daily basis. The nice thing, again, being that this updates on a daily basis. So if one card is super popular one week because it was just released, but by week 2 it's not popular because there's a counter or some new stuff that came out, this will dynamically update every single time. This is great, but it's, again, it is not personalized. So what did we want to do next? Well, the next thing we wanted to do was personalize all of our recommendations one-to-one with individuals. And this is where we started to be like, okay, we have a little more time. You know, we've got something that's currently running. It's making us money. Let's sit down, figure out something that's actually a little better. This is where we actually introduced the machine learning. So what we're doing here is, once again, collecting a bunch of data from the players. This time we're collecting a lot more, so we're checking what they buy, what they see. We're checking when they upgrade cards. We're seeing when they play cards. We're seeing when they favorite cards, anything that we can get about the players. We're once again processing that, cleaning it up, sending it to downstream tables. But we have this new loop at the bottom where we introduce a machine learning model. So we're training this model through Databricks, you know, uploading to the model registry, comparing the performances. And we've got these models, and we're training them, say, on a weekly basis. Every single day, though, or maybe every other day, what we do is we take that data that we're using for training, and then we pass it through the model, and we actually predict for every single player around the entire world, or at least anyone who's been active in the last X days, and we generate a set of recommendations for each of them. We take these recommendations, we ship them out around the world to all of these different key value stores, and when they log into the shop, because our shops are sort of synced, they update at noon PST every single day. We have like a window to upload before the next day. Once they log in, they get this new shop. It is personally, personalized to their exact patterns. And for example, if we run this model every single day for inference, it is updated to everything that they've done since at least yesterday. This gets us pretty close to what we'd like, and this is actually a pattern that we're using for a lot of things in the game. But I will caveat the one thing it's not great at is reacting to very time-sensitive things, right? Sometimes when people play games, they just unlocked a card, and right when they unlock that card, that is an amazing opportunity to do something in their game. Maybe they just got beat really badly. Maybe that is a good opportunity to do something in the game. Because we're batch pre-computing this, we're not able to quickly respond to all of these things. It is still dynamic, and so we find it's really good on these sort of more slowly changing patterns. So, you know, you might not change the general art style that you like every single day. You might not change the characters every single day, and if we're about a day late, that's okay. So again, we're using this for a lot. But the last thing that we have is actually having real-time data recommendations. So you'll notice this is very similar to the last one, but instead we don't have this extra inference step where we pre-compute batch of recommendations and ship those globally. You'll also notice on the right side, I no longer have a key value store. I actually have a model serving endpoint. So we take this model, and instead of keeping it in Databricks and just doing pre-calculated recommendations, shipping those out, we'd actually take those models and deploy them globally. We deploy these globally so that they're super, you just hit the main endpoint, it's low latency, it's very responsive, but then we also add this extra piece that I added at the very top, where we have the backend servers and we have a bunch of data about the players. So when people are actually playing the game, as we update their account data, as we trigger certain events, we're able to take the relevant data, pass it in to these endpoints, which are essentially machine learning models wrapped in a PyFunc that do a little bit of sort of reverse ETL, handling a little bit of logic. They combine whatever relevant information happened in the last 5 seconds, as well as the model, and potentially some pre-computed features for each of these players. And with all of that, we're able to, at runtime, generate something that is more dynamic. So one of the things that we do in the game for this is actually personalized bundles. Earlier I was talking about the shop, but for personalized bundles, we actually trigger it off of very recent things, so cards that you recently unlocked. When we give you a bundle, we want to pick you a card that is relevant to that, but also potentially relevant to your tastes. How do you do that in real time? You have to kind of build a system that has all these different pieces involved. So that's basically all I wanted to talk through, but hopefully you guys got a lot of information of like different types of ways that we've deployed it. We actually use all 3 of these systems in parallel, and you can combine a lot of them together. But in terms of extra things that you might want to consider when you're building this, you do want to figure out where does your logic actually go. We actually had a lot of back and forth. We wrote a lot of code, deleted a lot of code. We've been figuring out, do we want to put code that does the logic in the client? The answer is pretty much no. I'm not going to say you can't do it, but it's really hard to do stuff on the client. Client releases, especially for mobile games, are super slow, right? You have to get them through iOS approval and all these different things. So we try to avoid everything there. Sometimes we put this logic on the server side, but the server side also is kind of slow. We actually have to make a build. We have to test the build. We need to make sure we didn't break anything. But what we've really been moving more and more towards is updating things in our data service. And so that's when you might have heard me mention earlier, we have a machine learning model, but we generally wrap it around with a PyFunc. This PyFunc, like from MLflow, is just a very, very light wrapper that allows us to add really simple pieces of logic. This is great in 2 ways. One is in Python, which is much more comfortable for a lot of people who are developing these models, rather than forcing them to go into C# or C++ and whatever game engine, using packages like Link that are not super great for these processes. But it also allows us to deploy on our own cadences. So we don't have to actually match client or server upload cadences. We can just switch stuff out whenever we want, pick a model serving thing that allows you to promote models easily, and you'll be fine. Experimentation is extremely key here, right? So one of the big things is we want these systems to run by themselves. The problem is when they're running by themselves and training by themselves, you need to make sure that they are doing what you want them to do. So we are monitoring them. We are also experimenting with tons of different variations. So maybe we have something that's mostly targeting you just for what you play, something that's targeting you more for what you actually just buy in terms of cosmetics and the art styles. Maybe we have stuff that's working with all of those in between. We're launching new experiments on a weekly basis, analyzing them, and quickly rolling up and rolling back different things that we've launched. And the last thing is really, the first few might feel a little painful, but the more that you build, the easier it gets. Whether it's because all of these different pre-computed values can be used for everyone, right? So we might be using some pre-computed information to figure out what are cards that are commonly found with other cards. We might be using that to package your bundles. But then someone on the gameplay side is like, people hate deck building, and so we built out this system called Smart Deck, and it auto-completes your deck for you. Maybe those two can leverage a bit of the same information, right? So kind of get some scale as you build this stuff out. So final takeaways that I want to make sure everyone kind of like gets out of this, since I kind of dove a little more into tech than maybe some people wanted. But I think the most important thing is to figure out how you can shorten this loop on iteration, right? Instead of having this world where we get 10 new feature launches every single year, we're launching experiments every single week, and every single one of these experiments, even though it might not be a different model, is trying out different recommendations that we can analyze, different combinations of cards that are sent to players that we can look at every single day. And so we have fresh and new data to look at every single day to figure out and inform the next steps that we're going to take. Experiment often and measure everything. We've been really scaling up the dashboards and the reporting that we do on this area, and we're really trying to understand like what are the core metrics that we care about and what are the things that we can control. Building anything is better than building nothing. So I want to emphasize this because that first version I told you about with the simple version with cohorts and everything, it is not great, right? It does not not personalized for every single player. It takes at least 1 day to catch up with trends that are happening, but it's pretty good. We looked at a lot of the performance, and compared to the best machine learning model, the lift was more than 50% of that total area. And that entire machine learning model might take months to make, but that cohorted version that is segment-based, that takes a week. And the opportunity cost of what you might lose in that entire time is pretty massive when you look at a game that has a player base that is like trying to spend money but just can't find stuff to buy.
That's cool.
And finally, I think the key thing is to find the right platforms to use, right? You want to find a platform that kind of fits the needs that you have. Fortunately for us, Databricks kind of does everything we need. It handles our ingest, it handles our data processing. They've built a pretty good integration with MLflow and their own model registry, and it's pretty easy to then ship stuff out and connect. I think they're talking a lot about interoperability, and that's something that we really value because as I showed in some of the slides earlier, a lot of our serving is actually being done on SageMaker right now, but at the same time, some of our serving for other things that we're working on, both in R&D and potentially new things in staff, they're going to be using Databricks. And the fact that we have that flexibility is super great because for us, spinning up the SageMaker serving took like 3 seconds because our team is already very deeply invested. Like the engineering team is already deeply invested in the AWS side, but we have that flexibility where in the future, if we want to move over to using something like Databricks, it's possible. So thank you for all your time. I just want to give a quick call out that we all are also hiring. I know most of you probably have jobs, but thank you.